This is part of our video series on human-centered evaluations for NLP explanations. Check out the link for more resources. You're currently here. Welcome back to our explanation of explanations. In the previous videos, we talked about why you might want to explain an input to a human and some of the methods to generate those. But those methods seem pretty simple since they're just manipulating the input.
Yeah, we only covered some representative methods here. But even the more complicated methods share the same ingredients.
And it seems like all the methods that we talked about use the model's prediction probability one way or another.
Exactly. And you could replace that with other forms of uncertainty estimation. For example, you could use the calibrated prediction probability that we talked about instead. In general, uncertainty estimate is at the core of many post hoc explanation methods.
One of the things that we'll be talking about in this video is the limitations of explanation. So this seems like it's one limitation because we saw earlier that the uncertainty estimate is often a little imperfect.
Yeah, in fact, it can be very bad in some cases. There will be cases where removing a seemingly unimportant word like off causes a huge drop in confidence.
Okay, let me just put in a cute little acute accent on the E to make things a little bit classier in this example with the French spelling. And hey, it completely flipped the model's prediction. That doesn't seem right.
Yeah, and sometimes just pure gibberish can get high confidence predictions.
So I guess the takeaway is that once you get out of distribution, small modifications like removing of can make the input ungrammatical. And since the model only sees grammatical sentences during training, the ungrammatical input can make it really uncertain.
With input further away from the input distribution, such as sentences with unexpected code switches or just pure gibberish, the model's behavior becomes even more unpredictable.
I also noticed that when generating input attributions, you're always computing the score for one word at a time. We're not pounding rocks together here with a bag of words model. Doesn't the model use some kind of distributed representation for those words?
Yes, absolutely. And this can be a problem as well. We saw earlier that both not and administrative have pretty high confidence attribution score, which makes sense since when either one of those words is removed, the answer changes.
So I guess the natural question is what happens when we remove both of them together? The input becomes the rule of he who decides does apply to decisions.
This becomes the statement becomes a bit vague, but it's definitely implied by the context which says it applies to judicial decisions. Correspondingly, the model answers yes with lower confidence, let's say 80%. Comparing this to the original input, we conclude that the attribution score of these two words should be 12, which is not equal to 90 plus 72.
In other words, the attribution scores aren't additive.
This can be extra confusing since we're using a heat map to visualize the explanation, which implies that the model is doing some kind of weighted average of all words.
Wait, so if the attribution score of two words is not equal to the sum of their individual scores, isn't there some kind of inconsistency between the importance of an individual word and the importance of that word in a phrase?
Spot on. Even if we start computing attributions for bigrams, trigrams, or even all possible substrings of the input, we still have the issue that each attribution score is calculated within certain context. And this is yet another issue of aggregating individual attribution scores into a single heat map, since those scores are computed in different contexts.
This is what happened with my fancy French spelling of décision, caused the model to be insensitive to the deletion of not, right?
Yes. While the context doesn't look very different, the model treats it as different enough that the word not will receive a very low attribution.
So when we say that the word not is important, what are we really saying? We're saying that it's important in that specific context. This could also be an issue for word replacement, right?
Absolutely. Removing not and replacing administrative with judicial both flip the model prediction. But doing both changes at the same time
But
would
this
not.
means that the information provided by input attribution and counterfactual explanation are contradictory. After seeing these examples, I feel like the explanation methods are just broken and we shouldn't use them.
Not necessarily, but you're right. We shouldn't take them at face value. It's important to carefully think about exactly what information is provided by the explanations. From the last couple of examples, you might think that those are simply bad explanations because they do not align with human intuition.
Then what does it mean for an explanation to be good or bad then? If your input attribution highlights these unimportant words, is it a bad explanation?
If your goal is to persuade people that your model is reliable and you want your explanation to always look reasonable, then yes, it's bad. But it's a good thing if you want to spot cases where the model is sensitive to a feature that it shouldn't use. To use a more realistic example, you don't want to reject a job application but accept another when the only difference is the applicant's gender. That's illegal. But the information provided by the explanation becomes vague when the explanation itself becomes unstable. For example, when it only highlights words in very specific context.
So what's the takeaway here?
We think developers of explanation methods are not necessarily informed to make a value judgment about what makes a good
Then who
explanation.
the heck is?
How you use the tool is what matters. So you need to have user-centered evaluation with the user in the loop.
Luckily, that's what the next videos are about. This video isn't the end. You're currently here. If you're lost, click on the link below for source code, slides, and other resources.